You can build a multi-agent AI demo in a few hours, but the moment you scale it for thousands or even millions of users, your architecture starts to break down. Standard HTTP connections start to time out while your agent is still reasoning. Agents have no standard way to discover each other's capabilities. And passing raw text back and forth quickly burns through your limited context window. These are the exact problems your agent-to-agent protocol, also known as A2A protocol, is designed to solve. A2A protocol was released in 2025 by Google Cloud with its 50 plus technology partners and was made open source. Before A2A started to be widely adopted, the organizations that were trying to scale their apps from mere demos or vibe-coded applications to production applications were facing several challenges, especially in production because their architecture was breaking in different ways. In this video, I'll help you build a complete mental model of an A2A application. Here's a fundamental architecture of an A2A application. I know it looks complicated right now, but by the end of this video, you'll have a complete understanding of this system. You will be able to trace how the request flows through an A2A application. Let's understand this architecture from the angle of a simple client server. A client is any agent or application that sends the request to the server and accepts the response. A server is any agent or application that accepts the message and responds back to the client. Let's take a simple example of a travel booking request. Client sends a message, book a flight from San Francisco to London for August 14. The HTTP layer's job is to accept the request and pass it straight on without looking into the contents of the request. In this HTTP layer, A2A is essentially solving the discovery problem. How does an agent learn about the capabilities of another agent? A2A solves this by giving every agent something known as an agent card. An agent card is nothing but the profile of an agent. This agent card shows the description of the agent, its skills, its capabilities, and any authentication required. So when a client sends this request for the first time to this server, the server starts and the agent card becomes accessible at a particular endpoint of this domain. Next, the protocol layer. The protocol layer is where the real work starts. First, it validates input data, whether it's JSON, RPC or not. This layer extracts the data in the A2A format, such as message, parts, etc., and combines all the data into one single JSON object. A part is a small unit of data within a message in this A2A protocol. This layer also creates a task object for the agent if needed. This layer solves the timeout problem. An AI agent needs time to reason. Sometimes it loops several times to be able to solve a task, while the standard HTTP connections time out in 30 to 60 seconds, and this causes the request to error out. A2A fixes this by creating a task object for the work that runs behind the scenes for as long as it needs. But what happens when an agent needs to ask the client for any clarifications or needs any inputs? Without A2A, this task would fail. But A2A prevents the task from failing by providing something known as a state machine. The protocol layer then transfers the entire data in a JSON to the agent executor, which then extracts all the data into a free text string to send to the agent. So why is agent executor even needed? And why can't we just send JSON RPC document directly to the agent? Why do we need to send the free text? First, your agent was created maybe using some of the frameworks like LangGraph or even Crew AI. Some of those frameworks might not know about A2A protocol. So they might not be able to parse things like part or message or terms that are specific to an A2A protocol. So this layer, agent executor, ensures that the framework of the agent does not need to understand A2A at all. Second, a language model's context window is limited. Sending heavy protocol data to the agent would waste precious tokens and also would degrade the performance of the agent. This effect of decrease in the quality of the response with an increase in the context window essentially degrades the transformer's attention mechanism, an effect also known as context rot. In our case, the agent executor ensures that the model uses the tokens only to solve our task. An agent reasons uses loops and function calls to be able to return the raw response to the agent executor in whatever format the agent is designed to return. An agent executor is a wrapper code that a developer needs to write in order to translate the raw text response from the agent back to the protocol layer. And it also publishes events one at a time. Now, what are these events? Tasks usually have status updates for the client. These status updates are known as events. There's another term known as artifact. Artifact is essentially the final response to the client. It could be any data type. It could be a file, it could be a raw text, it could be any other data type. So an agent executor returns not just the final artifact, but essentially all the events or all the status updates back to the client. Example of these events could be working currently or input required or completed. So you can see that a task object is extremely important in A2A protocol because it enables the A2A server to be able to send the status updates back to the client, especially for long running tasks. Now this communication from the agent executor back to the protocol layer happens via event queue. The problem that this layer solves is the agent returns the response in the format of different data types. For example, it could return a file or a raw text. Now, this unorganized data can cause problems in production. Now, A2A organizes these different data types together into messages or artifacts. The two things happen when the data flows from agent executor back to the protocol layer. The response gets written into a task store and is also sent back to the protocol layer. This solves the problem of visibility because you cannot let your users stare at a blank screen while the agent takes several minutes. So A2A gives you an option to stream the status updates or the events while you are waiting for the final artifact or the final response from the agent. The protocol layer wraps the response in A2A format, and the HTTP connection essentially writes the response back to the client. The client also receives a response in A2A format. For a continuous streaming task, the last three steps, 7 to 9, run in a loop as long as the agent produces something new until the final status equal to completed closes the whole stream. All of the solutions that we discussed come together to form the A2A protocol. Two things you'll notice once you've gone through the whole data flow. One is that the protocol layer is only ever touched twice, once when parsing on the way in and second when wrapping back to the protocol on the way out. Second is the agent executor is the only box in the whole architecture diagram that essentially talks to your agent. I've created a complete guide on A2A that you can use to learn more and implement this in your own agentic system. Check out the link in the description below.